All right, welcome back to Eureka Math. I'm Mr. Shankel. Today I'm going to be helping you with Module 3, Lesson 19. This is Part 2. Let's get started. Well, we ended by finding the area of a rectangle of size 9 by 8, and we found that the area was equal to 72 square units. There would be 72 of these boxes in here if we counted them all out. And now we're asked to do something new with a diagonal line. So go ahead and pause the video, figure that out, and then come back and we'll show you the solution. All right, so here we go. We're going to draw a diagonal line segment through the rectangle with opposite vertices for endpoints. So I'm going to use this side for one of my endpoints. I'm going to go through the rectangle all the way to the other vertice, which is the corner, and I have a diagonal line. And then the question is, what geometric figures are formed by this line segment? Well, I've turned my rectangle into two triangles. So the triangle is what has been formed, and I have two of them, and they're going to be of equal size. So the question now is, what are the areas of each of these figures? Since we split the rectangle in half, we're going to do the same thing with our area. So each triangle is going to be 36 square units. Each triangle is half of the rectangular area. All right, let's go on to number 7. Go ahead and pause and finish number 7, and we'll come back and show you the solution. So here we are. Construct a rectangle on the coordinate plane that satisfies each of the criteria listed below, and identify the coordinates of each of its vertices or the corners. Okay, so here we have some conditions we have to satisfy. Each of the vertices lies in a different quadrant. So I'm just going to go ahead and pick a few out that are in different quadrants. There's quadrant 2. I'll put one here in quadrant 1, and down into quadrant 3, and then the last one in quadrant 4 is going to be right there. So there's my rectangle. I noticed that it says my sides have to be either vertical or horizontal. I did that. Let me put in our lines here. So I've got one side that's right there. I've got a side here. I have a side here vertical, and one more horizontal side. There's my rectangle, and the perimeter has to be 28. Now maybe I got lucky, but I'm not sure. I'd have to find out what the perimeter was. So we may have to go back and fix this. Let's see. I have 3 on the positive side, and I have 6 on the negative side. So this is a 9. And then on my vertical line, I've got, 4 on the positive side, 3 on the, so that's a 7. And 9 plus 7, that's 16. And if I double that, it's 32. So my perimeter is 32. That's too big. So I need to adjust this in some way. And I think what I'll do is I will take off some of this end. So if I take 1 off on each side, I'm going to drop 1 unit of perimeter. So that would be 30. So I think I'm going to need to take 2 of these off of here. Okay, so like this. And then I'm going to reapply my points and draw the last segment of my rectangle right there. And now let's recalculate here. I've got 1 on the positive side on my horizontal line, and 6 negative. So this is a set length 7, and I still have 4 on the positive side, 3 on the negative side. This is also length 7. So 7 times 4 is 28. That's going to work for me. I've satisfied the last of my conditions. So now I need the vertices. So what are these 4 points? So I'm going to write them down here. I've got, let's do this one first. 1 to the right and 4 up. So that's the point 1, 4. And I've got 1 to the right and 3 down. So that's the point 1, -3. And then I'm going to go left 6 and up 4. So that's a -6, +4. And then I'm going to go left 6, down 3. So that's a -6, -3. Again, your points could be in a lot of different places. As long as the perimeter was 28 and you've got vertical and horizontal lines with different quadrant points, you're going to be in good shape. Probably not what I have here. Now I'm going to use absolute value to show how the lengths of the sides of the rectangle provide a perimeter of 28 units. So I can see here, let me get a new pen. I can see here that my different values are my y value here. So I have a 4 and a -3. They're opposite sides of the number line, so I'm going to add those absolute values. So I have the absolute value of 4 plus the absolute value of -3. 4 plus 3 is 7. So I can see that my vertical line, this one, is going to be 7. So that's good. And then I'll go down here and check the horizontal line, and I can see that, let's see, right here I have a +1 and a -6 are different ends of the number line. So I'm going to add again. I'm going to add the absolute value of 1 plus the absolute value of -6, and 1 plus 6 is 7. So I can see that this distance, the horizontal line, is also 7, and I've proven using absolute values that both my sides are 7 and the perimeter is 28. All right, that is lesson 19. I hope that helped you, and I'll see you again next time.